Question. Now, circle theorem question is generally one of the poorest questions done on the paper. It's on trigonometry and I don't know why, and it's so easy. All right. So looking at this question, it says the diagram below, not drawn to scale, shows a circle. The points P, Q, R, T, and V are on the circumference. Q, R, S are in a straight line, and angle PVR is 75 and angle TRS is 60. And it says determine each of the following angles. Show detailed working where necessary and give a reason to support your answer. Angle PTR. Find out what is angle PTR. Angle PTR. This angle. All right, so we want this angle right here. Now this angle right here is going to just be 75. You might wonder, how do I know that angles subtended by the same arc are equal? So this angle 75 is equal to this angle 75. All right. Just to go back to circle theorem rules, I'm just showing you a preview. All right. Angles in the same segment from a common chord are equal. So as you can see, this angle is equal to this angle when they're from a common chord. So they're subtended by the same arc. All right. So again, the common chord right here, this is a common chord. And so of course, these two angles are equal. They're subtended by the same chord. All right. So what that means is that it tells us so many information. Because they're subtended by the same chord, and what that means is that this angle I got equal this angle. This angle here, so I got equal this angle too. Right? So if this is x, then this is also x. And if this is, call it dot, then this is also a dot. All right? Now, why do I need to know that? Now, I just want to know that because the next one that we want to find is angle PTR is equal to 75. And the reason angles subtended by the same chord are equal. Angles subtended by, subtended just mean formed. Angles formed from or by the same chord are equal. So that's a 75, nice and easy. All right, so that's that reason. Let's look at what they want next. Next thing they want is angle TPQ. Angle TPQ. So they want this angle. So I'm going to call this angle theta for now. So I want to find theta. Now this looks pretty difficult to find. Now let's see how we can find theta. Now from what I am seeing is, if this angle is this is 75, this is 75. All right. By z angles, x equals 60. By z angles, x equals 60. All right, so I'm just trying to decipher what theta is. You might see an easier approach. Nothing is wrong if you see an easier approach. By z angles, this is 60. And if this is 60, then this is 60. All right. And then if this is 60, then I can find dot. Then dot is going to be 180 minus 75 plus 60. So that means that dot is 45. This is 45. If this is 45, then also this is 45. You're wondering, why am I finding so many angles to get to theta? Because I don't see the direct route to get to it yet. So I'm hoping that this will help. Now what I notice is that P, V, R, and Q are 4 points on the circumference and they form a quadrilateral. So this is a cyclic quadrilateral, and opposite angles or opposite sides of a cyclic quadrilateral sum to 180. So I then know that the angle at Q here is 105. So if this is 105, now opposite angles in a cyclic quad, I also say that T, P, Q, and R form a cyclic quad. So I know that theta plus the angle all around here should sum to 180. So how am I going to find theta? No worries. No worries. Take a little while sometime. Let me see how we can decipher theta. Good. Look at this. Angles on a straight line is 180. So this angle right here is 120. This angle right here is 120. And this angle right here then is 120. All right. By supplementary angle. So this angle is also 120. All right. So what is that telling me now? Now this is 120. How is this useful? How can we make this useful? So we know this angle is 120. Let us see now. This angle is 120. This is 105, 45. We still don't get what we want. We want TPQ. We want this angle theta. It should lead somewhere. Don't worry about it. All right. So we know this is 45. Ah, there we go. There we go. We find it now. Now this angle right here, angles on a straight line is 180. So if this is 60 and this is 45, then the angle right here is 75. Cool. This angle is 75. Now, according to the cyclic quadrilateral, angle P in the quadrilateral TPQR, if this is 75 and this is 45, we add those together to get 120. And 120 plus the angle at P should be 180. And so theta equals 60. So this angle is 60 degrees. All right, I know I found all of the angles which I didn't have to do, but sometimes it's depending on what is coming to you. You just want to make sure your answer is correct. It's just depending on what's coming to you. All right, so this angle is 60 degrees. All right, to give a reason, well, I did so many reasons and I showed so many workings. All right. So in reality, in final check, you can just tell them that in a cyclic quad, you found this angle to be 75. So tell them that the angle VRQ is 75. So angle VRQ equal 75 and angle, I was trying to write it a nice way, and angle TRV, angle TRV, and angle TRV equal 45. All right, we're not done yet, you know, we're not done yet. After you tell them that now, then you're going to tell them some more stuff. You're going to tell them, no, you're going to tell them that the thing forms a cyclic quad. No, or tell them PTRQ forms a cyclic quad. TPRQ, no, TPRQ forms a cyclic quadrilateral. I know I'm not spelling this right. Quadrilateral. And so the angle at P and the angle at R in the cyclic quad sum to 180. Hence, angle TPQ is equal to 180 degrees minus the sum of the 75 plus the 45. That's all you have to tell them. All right? And that's how we find angle TPQ. So again, just to refresh our memory of circle theorem, you need to know all of these rules, all right? The angle at a semicircle is 90. Also, I want you to know that any two chords that are connected to the diameter, that angle is also 90, all right? The angle between a radius and a tangent is also 90. Angles in the same segment subtended by the same chord are equal. Angle at the center is twice the size of the angle of the circumference. Opposite angles in a cyclic quad sum to 180. Angles in a cyclic quad sum to 360. Alternate segment theorem, the angle between the chord and the tangent is equal to the opposite angle inside the triangle. All right? So alternate segment theorem is very powerful. A lot of times don't even utilize this one. So these are just the theorem again, guys. Two tangents to a circle from the same point will have equal length, and then the radius through the midpoint of a chord will bisect the chord at 90 degrees. These are all the circle theorems that you'll need to know for CSET math. 8 little theorem. All right, come on, man. These are easy. So just continuing now, it says obtuse angle POR, where O is the center of the circle. Angle POR. Angle POR. And that's 120. So we have it right there already. Angle POR. This one right here, which is just 120. All right, angle P. Wait, where is O? There's no O right here. That's crazy. They didn't. Let me read this again. Where O is the center of the circle. That's crazy. That's crazy. Now, guys, they say O is the center of the circle. So what that means is right here, so this is not the center. This chord VR and this chord PE intersect here. That's not the center. That's because these chords are not diameters. So wherever the center is, let's say the center is right here. If the center is right here, they want the angle P. This is what they want in black. Follow this line. They want angle PO. Let's say this is the center. They want angle POR. Now, angle at the center is twice the size of angle at the circumference. All right, when they're formed by the same chord. So angle POR is 150. That's crazy because they didn't put O on they didn't put the center on there. So you would have to just know that angle at the center is twice the size of angle of the circumference. So angle POR is equal to 150 degrees. And the reason is angle at the center is twice the size of the angle at the circumference. All done. All right, now next part, it says a person at the top of a lighthouse TB sees two ships S1 and S2 approaches the coast as illustrated in the diagram. The angle of depression are 12 degrees and 20 degrees respectively. The ships are apart by 110 meters. Complete the diagram below by inserting in the angle and the distance of the ship. So all of them are asked us to do put in information with them tell we. So then they tell we say TB sees two ships S1 and S2 and the angle of depression are 12 and 20. A person is at the top of the lighthouse TB. So the person that up here, so all right, and the angle of depression from S1 and S2 are 12 and 20. All right. So from position, it's always a from 12 and 20. So from position, angle from is 12 and 20. We put this right here. This angle right here is 12 degrees. I don't even want to squinch it, so I'll put it out here. The from position is 12, and then from S2, angle from S2 is 20. And then what else then tell we say? Them tell we say the ships are 110 meters apart. So the distance between S1 and S2 is 110 meters. That's all they give away. I'm not giving nothing crazy. All right. The distance between the ships are 110 meters apart. So that's it. We're good. All right. So that's it. So now let's work out what we need to do now. Let's say determine to the nearest meter the distance TS2. So they want to find the length of this line TS2 between the top of the lighthouse and ship 2. So of course we're going to do some trigonometry right here. So doing some trigonometry, if this angle is 12 and this angle are 20, then I just want to put in that this angle right here, so I'm going to be 90 minus 32. 90 minus 32 is 58. And if this angle is 58, I just want to say that this angle right here is, in this triangle right here, this angle is going to be 32. And if this angle is 32, this is 58 and 12, that's 70. And so this angle right here is also 20. You might wonder why I'm right, why am I putting on all this unnecessary information? It makes it easier later on down the paper. Just write down everything that you know. So you want the distance T S2. The distance between T and S2. Right here, so this distance. So we need to find the hypotenuse. So let's see how we can find the hypotenuse. All right, so we want to go in this big triangle here. Now we're going in this big triangle. We're going in the triangle TBS2. We have all the angles, but we only know the distance between the two ships. So going in this triangle, and guys, you might see me do this a lot, but this is just for me. I like to sketch what I'm doing. So I'm just taking out a sketch of what I'm doing. This is the triangle we have. All right, I'm just taking out a sketch. This is S1, this is S2, S2, S1, and this is T. I just like to sketch what I'm doing. And I know that this distance is 110. All right, S1, S2. I know that this angle is 12. This angle is 12 degrees. I know that this angle is 20. And this angle is, if this is 12 and this is 20, angles in a triangle is 180. So 12 plus 20, 180 minus answer, this is 148. This angle is 148. And you might say again, sir, why are you doing all of this? For me, it's easier. So now guys, I'm going to use sine rule and find TS2. According to sine rule, I can say TS2 over the sine of 148. TS2 over the sine of 148 is going to be equal to 110 over the sine of 12. And so all I do is cross multiply now to get TS2. So by cross multiplying, I get that TS2 is equal to 110 times the sine of 148. And this is all being divided by the sine of 12. All right. You might say, whoa, I did it in a lot of steps, but that's just me. I like to visualize what I'm doing sometimes. It makes it a lot easier for me. All right. So visualize what you're doing. So 110 sine 148, and you divide that by sine of 12. I'm getting 280.4. So TS2, I'm getting 280.4 meters. Nice and easy, 280.4. And it said to the nearest meter, so let's just drop off the 0.4 and put 280 meters. So that's TS2. Now it asks for the height of the lighthouse TB. Now that we know that the hypotenuse is 280, then we can use anything and find the height right here. We can use cosine rule, we can use sine rule, we can use trig ratio, anything you want to do, right? So let's say you know that this length is 280 now. So let's go ahead and use sine, because we have theta as 20 here. So let's using sine. We're using SOHCAHTOA. So we know that sine 20 is equal to the opposite TB over the hypotenuse of 280. And so what we're getting then is when we cross multiply, we get TB. Did I use the right angle? Check if I use the right angle of 20 degrees. Yes, I utilize the right angle of 20. All right, and so TB is going to work out to be equal to sine 20 times 280, or some would say 280 sine 20. And so you work that out, 280 sine 20, you work that out, and you get your angle. You get your length of TB. So 280 sine 20, I get 95.8. I get 95.8 meters. 95.8 meters. Nice and easy, soft, a capital P.